I'm recording this with a different program, and I'll post this on YouTube for your reference. Anyone who has a microphone, can you say hi? Anybody? Okay, maybe you... okay, there we go. Very good. Hello, hello. I don't know how it's going to work if you have a question or not throughout the course of this, but please ask questions. And but this PowerPoint, it's really not bad. It's kind of the same as the other ones, you know, where it's, you know, the recognizing what an amine is. We get into something called an amide, and then towards the end there we get into amino acids. And the reason why, what do we got here now? Your quiz 5 is
to ask on here or write it in the chat.
Sorry. Hello?
For any questions?
Yeah.
Do you want us to just write it in the chat or just turn on our mics?
I don't know. I'm just trying to find out where the chat is. Where is that? It there? Start private chat with this participant. Yeah. Maybe. Who am I speaking to?
Jenna.
Okay. Hi, Jenna. Can you send me a message? I don't know. Type something in there, and I just want to see where it pops up, because I can see there that I can message any of you. Well, I can only see 4 for some reason. I don't know where everyone else is. And if you message me something, I don't know where it's going to pop up. And okay, yeah, okay. So that's yeah, it just popped up and it went away. Okay, all right. I don't know. We'll just play it by ear. And if you have any dire questions, throw them out there some way, somehow, and we'll get through this. And as I said, this PowerPoint isn't bad. It's like 55 slides. It's kind of longish, but it's not bad at all. And if you gotta go away, you know, go get a coffee or go whatever. Again, I am recording this and I'll post it on YouTube, so you're not going to miss anything. All right. Your quiz 5 that was handed in there this week. I think your lab number 5 was supposed to be in there last night, and they all look good. So don't, you know what I mean? You guys are going to do great on this. Your test is next week. I'm going to post quiz 4, quiz 5, and I think your quiz 6 is due there. I don't know. I think it's due on Monday or Sunday or Saturday or something like that. So that's you're going to have all the answers there for quiz 4, 5, and 6, and they're all multiple choice because your final is going to be multiple choice as well. Okay, and you're going to see a lot of repetition. Like one of the reactions that we've talked about there in the past couple weeks is oxidizing, you know, an alkane into an alcohol. And then if it's a primary alcohol, we can oxidize it into an aldehyde, and then you can further oxidize that into a carboxylic acid. We've hit that there 3 or 4 times. If it's a secondary alcohol, then you can oxidize that into a ketone, but then you can't oxidize a ketone any further. And like, there you go. There's a couple of exam questions right there. So what I just spoke about right there, write that down, go over that. That'll be 3 or 4 questions on your final. Okay. I still haven't worked out the details of your final. I kind of, you see I'm giving you your quizzes in the fashion where you download them and then you take a picture. It's working fine. Please make sure that it's a JPEG or a PDF or something like that. I know people's printers have been out, so they've been giving me the answers on a printed piece of paper. It's all good. Whatever. Okay. What else? So I think we're pretty good on that. Yeah. So if you guys have any questions, let me know. If you don't feel like chatting now, shoot me an email. And I apologize for any hiccups if there has been any. but just email me and we get you guys through this. As far as I can see, you guys are all doing great anyway. Okay. With no further ado, if you guys don't have anything, let's rock and roll. Now, today, the last lecture there is amines, and when you think amines, think nitrogen. That's all this is. Okay, and when you, it's not really as far as a food source goes. Of course, the body goes after carbohydrates first. Okay, fats second, nitrogen based like protein. It's protein is just another word there for compound there that contains nitrogen, and it's not really a great food source, and not easy to break down, and once you do break down, and there's not a lot of energy within it. But I don't know, can I move this? Yes, I can. Okay, perfect. As with alcohols, there are primary, secondary, and tertiary amines, and it means the same thing. A primary amine, like this one right here, is a nitrogen attached to one carbon. A secondary amine is a nitrogen attached to 2 carbons. And a tertiary amine is a nitrogen attached to 3. And the nitrogen has an oxidation number there of -5 or of -3. All right, so it can only make 3 bonds. That's it. So nitrogen will always have 3 bonds. Doesn't matter if it's like ammonia here, NH3, or here we have methylamine. Okay, and here we've got an ethyl group and a methyl group. We'll get into nomenclature, okay, and all that. But just know that nitrogen will always have 3 bonds. And it could be a primary, secondary, tertiary. All right. Notice here the benzene. And please take note of this. I will get you on the final there for this. The amine with a benzene, it has a name, and this is its name, aniline. Okay? And please know that this is not a benzene. This is cyclohexane. Okay? And so please know the difference between the two. All right? Next. Skeletal structures of amines. Okay? Again, we have a primary amine where it's a NH2 group on the end. Here we have a secondary amine, okay, where it's the nitrogen is attached to 2 other carbons. And here we have a tertiary where the nitrogen is attached to 3 other carbons, okay? And anyone who just joined, hi, how are you? I hope you guys are doing well. You guys are doing safe. You haven't really missed much, and if you did, I've been recording there for the past 10 minutes, and I'll post the whole thing there on YouTube after here. So if you got to go away for 5 minutes or 10 minutes or whatever, don't worry, it's all being recorded anyway. Let's have a look here. So classify the following amines as primary, secondary, or tertiary. So you have this guy here. Okay, here's your aniline. Here we have this guy here, and be careful, this nitrogen is attached to 1 carbon, and then you'll see it written as this nitrogen is attached to CH3 with a 2. Now when you see CH3, remember I've said this there in the other PowerPoint videos, that's a terminal carbon. CH3 is always a terminal, so here you have a CH3 coming off here, and you have another one coming off here. So this one here is a tertiary. All right, and then we have this guy here where this amine is attached to this carbon, and it's also attached to here, so it would be a secondary, and the answers are here. Okay, so being able to tell a primary, secondary, tertiary amine, it's kind of the same but a little different there than alcohols, but being able to identify primary, secondary, tertiary alcohol as well. There's a question or two in the final as well. Naming. Now, make it make sense here. What do we got? Here I have ethane with an amine on the end, and just ethanamine. That's all it is, right? It all goes back to meth, eth, prop, but, pent, hex, hept, oct, non, and dec. All right? And the reason why there is no number here, okay, is because I can't have this amine anywhere else. Okay? If this amine is on this carbon, well, it's still the same thing, just flip it around 180 degrees. So it's just ethanamine. But here I have propanamine, 1, 2, 3 carbon. This amine is on the number 1 carbon. But remember, if I can put a 1 there, there's got to be another place where a number can go. And there, this amine can actually come off the number 2 carbon. And in this case here, it would be 2 propanamine, as in this case right here. Okay? Have a look here. And again, you find your how you do these, because they're all going to come in mashed potatoes. You never know which one's going to come next, right? So you identify this as an amine. Okay, there's your functional group. Now find your longest carbon chain, and you've got 1, 2, 1, 2, 3. So that's going to be a propanamine. Name the location of the amine. It's coming off of the 2 carbon. So 2 propanamine. And remember, you always start with the backside. Always, for every single one of these, you start backside and work your way forward. So here we've identified 2 propanamine, and then your longest chain here, there is a side group coming off of it. It's on the 2 carbon, so it'll be 2-methyl 2-propanamine. Okay, if the amine was on this carbon here, it would be 2-methyl 1-propanamine. Here we've got this one here. This is not benzene. This is cyclohexane. Okay, and here we have the amine group, so just simply cyclohexanamine. And remember, there's no need for a number, because if this guy was coming off here, then it would be the same thing. We're just rotating it. All right. If you have any questions, let me know. Now, getting into naming. If you go back here, these guys here are, they're all like primary. Okay, kind of easy peasy. These guys here, now if you have secondary and tertiary, see if I can do this here. Right here. Now, you have a look here. This amine is in the middle of a chain. So it's connected to this carbon. It's also connected to this carbon. We use the donation, or the term N, to talk about this situation. So 1N, sorry, I'm just kind of zooming out here. Do I have any? Yes, I do. 1N indicates a secondary amine, that it's attached to this guy here and this guy here. So we use N-methyl 1-propanamine. And why do we do that? So we use a prefix with a capital N if the amine nitrogen has an alkyl group attached to it, okay, and N-methyl 1-propanamine. So take your shortest group, and that goes with the N, and then your longest group, 1-propanamine. Have a look at this one here. Now I have a tertiary amine. So you're going to have 2 N's, and you must have 2 N's. If you got a tertiary amine, you got to have 2 N's in your answer. If it's a double, okay, a secondary, you're only going to have 1 N. So in this case here, here's your amine, and how would you identify this? you look at this beast here and you go, okay, I got a butyl group here, I got a methyl group here, I got an ethyl group here. Okay, but this is an amine. So right off the bat, start from your backside. Amine. Where's my longest chain? Butane. Okay. What location is the amine attached to that longest chain? It's coming off the 1 carbon. So it's 1 butanamine. So all from here to here, we're done. Now you need to identify these 2 groups coming off of this guy here, and you go alphabetical. So N-ethyl, N-methyl, 1 butanamine. Tertiary, you got to have 2 N's in there. You look at this one here. Now, here you've got this group coming off of here, and you've got 2 methyl groups coming off of this amine. So this is a tertiary again. You're going to have, you identify your longest chain. All right, so you got 1, 2, 3, 4, 5. All right. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's going to be a pentane. And because this is an amine, it'll be a pentanamine. Where is it touching? All right. On the 1, so it'll be pentanamine. All right. And what we've got here is 2 methyl groups coming off of here, so it'll be NN dimethyl. All right. And the only thing there we didn't talk about was the side group coming off of here. If we go 1, 2, 3, 4, 5, there's your pentanamine. But on the 1, 2, 3 carbon, we have an ethyl group. So 3 ethyl, 1 pentanamine takes care of all this. And then we got NN dimethyl. All right. Practice these a couple times. There's the questions and answers are posted there in Blackboard. Once you do these a couple times, and of course the test is going to be open book. So you're going to have all of these with you. And might I suggest you, in preparation there for the test, it is open book, so use whatever you can. All right. It's just going to be multiple choice. And that's why I've given you their quiz 4, 5, and 6 as such. They're all multiple choice. You might even see a couple of those questions again. All right. But might I suggest there is that you have some reference notes. Maybe you want to cut and paste all these, like this right here. This is movable. So you could go and create a Word document with titles there, alcohols, carboxylic acids, esters, all these kinds of things and how to name them. You know what I mean? Why not? Okay. What do we got here now? And you have a look here. Here again we have an amine. Now who's the big boss here? Where's my longest chain? Well, we've got a cyclopentane. So that'll be cyclopentamine. So that's all of that. And we've got a methyl and another methyl. So this is a tertiary amine, so there has to be 2 N's, so it'll be NN dimethyl cyclopentanamine. Okay. You have a look at this one here. This is primary amine. It's going to be, but you notice here we have 2. So it'll be a diamine.
No, they can't see you.
Hello? Everything good? All right. Perfect. If there are any issues, you can't see anything or can't hear me or anything, just shoot me a message. This is my first time using WebEx, and I actually quite like it. At some point in time, I'd like to become an expert at it. But just be careful here. Here I have propane with a diamine. And where are the amines? They're on 1 and 3. All right. Here we've got 1,6. Hexanediamine. All right. So there's your hexane, and your amines are on the end. So practice those a little bit, and they are what they are. All right. What do we got here? Benzene. Okay. an amine with a benzene, there is one name for it, and it's called aniline. And you'll remember there, I don't know, I think it was what, week 10, was it week 11? I don't know, where we talked about the benzene, and I added there that separate 3 or 4 pages of naming benzene. Naming benzene is an ugly thing, because some of them there, most of them there, we go IUPAC, but there are a couple of them there that they have their own name. So that would also be a good one there to have printed out there for the final test. Okay. Have a look here. Here we've got a secondary N-methyl aniline. All right, N-methyl aniline. Here we've got a tertiary. Okay, so this guy here will be aniline. And because it's tertiary, we have to have 2 N's, NN dimethyl aniline. You have a look here. This is a tertiary. And here's your aniline. And then you have N-ethyl, N-methyl. Why is it like that? Again, we're going alphabetical. So it's kind of everything there that we've learned there from the first week back after spring break. Okay. What do we got here now? Orthometa also follows. There's nothing different here. You have a look here. We have orthomethyl aniline. Okay. Nothing crazy there. Here we've got meta-methylaniline, para-methylaniline. You have a look here. We've got N-ethyl aniline. Okay. Why is it only one N? Because it's a secondary amine. All the rules kind of follow the same thing here, so you guys can have a look at those. You can pause the video later on, or we pause it right now, try these out. But finding the names for these, again, this is exactly what the final is going to be. How do you name these guys here? So again, the first thing you want to do, you identify that it's an amine. So you would write amine. And find your longest chain, 1, 2, 3. So it'll be propanamine. Where's the location? Well, this guy here is on the 1 carbon. All right? Because in theory, it could be on the 2 carbon attaching here to the nitrogen. So 1 propanamine. And because it's a tertiary, I need 2 N's in there, N-ethyl, N-methyl, 1 propanamine. And anyone there who just came in, hi, how are you? You didn't miss anything. I'm recording this and we'll post this there on YouTube. You're good to go. Welcome aboard. Hopefully there you can hear me. Okay? So if you just joined in, don't worry. I'll post this there, where to find it there. Well, you guys have all seen my videos there on YouTube anyway. So this one here, okay, this is the primary amine, so it's attached there to this carbon here, but our longest chain is 1, 2, 3, 4, 5. So it is the pentanamine location 3 pentanamine, because there could be a 2 pentanamine. There could also be a 1 pentanamine. Please remember that. If it needs a number, that means that there's a possibility of another number being there. But if there is no possibility of it being on another number, so to speak, then we don't need it. I don't know if that made sense.
Ian?
Yeah?
What time is our exam at?
That I'm still I'm going to work out, because in theory, I would like to have it, I'm sure you guys have taken multiple choice tests on Blackboard where you just go through each question and it skips to the next one. The problem is that this exam is all diagrams. It's all exactly these right here. And I'm having a tough time getting these guys up on Blackboard as far as making a test goes. So what I'm thinking is how your quizzes have been going. You guys download your quizzes, you print them off, and you hand in the answer sheet. You know what? I think it's worked well. I just might do that, and I'll open it up. I can't give you 3 days to do it like a quiz, but I can give you like 12 hours to do it. So I'm thinking they're opening it up next Wednesday at like maybe 10 o'clock and having it shut down at 10 o'clock at night. And, so it's open for 12 hours, gives people time to do it, do research, print it all off, or take a picture, send it to me, and I mark it like that. I'll let you guys know, but you guys will have more than enough time. It's not going to be a 3-hour time test where you can't get up and walk away. You're going to have your enough time there. Everyone's going to do well. So as far as to answer your question, that's where I'm at. Is that, and I'll update you guys further there this weekend. Is that cool?
Thank you.
Perfect. All right. So physical properties. Amines, they are flammable. And this is interesting. In some of the videos there, I talked about that somewhere in and around 4, 5, 6 carbons, these chemical compounds start to become insoluble in water because the number of carbons, like carbons and hydrogens, tend to be, what's what I'm looking for, nonpolar. All right, water is polar, so the more nonpolar carbons there that you add to the chain, the more insoluble they become in water. So here, aliphatic amines with up to 6 carbons, they are soluble in water. And like for carboxylic acids, I think it's 5, these kinds of things. Alcohols, I think it's up to 4. Methylamine, ethylamine, they're extremely flammable. And there's one there, trimethylamine, which the fishy odor. The amines are responsible for the strong odors of decaying flesh. And you'll have a look here, putrescine, okay, is 1,4-butanediamine. And here we have 1,5-pentadiamine cadaverine. So it all has to do with bacterial decomposition there. Okay, so it's that bad smell that you get after maybe you throw a meat wrapper or something there into the garbage, and then there's that putrid smell. Well, that's the amines that's the bacteria breaking down the nitrogen compounds. Okay. Here we have alkylation of ammonia and amines here, and what we're doing here we're starting off with ammonia, NH3, okay, and we're adding bromomethane. And what do we get here? You're adding a carbon group to this guy here, okay? And then you can keep adding carbon groups, and you'll see here that we've now made a primary amine. We can add another one there, which would turn it into a secondary. We can add another one there, turn into a tertiary. We can actually, because of nitrogen's electron configuration, we can actually add another one on here. You can actually make a tetra, 4, what we call a quaternary. Okay, and so you can have a look at that. We call that a quaternary ammonia salt. See, this one actually is an ion, actually has a charge. All right. The opposite here, we can reduce. I don't think I'm really going to go into this on the test. I don't think so, because here, you guys, if you were in my Chem 08, and I tell people there that what's the oxidation number there of hydrogen? It's +1. Well, the hydrogen can also have an oxidation number of -1. And so it's a little different. But here we have, okay, we're going to get into this there today. It's called an amide, all right? But in the reduction there of an amide bond, you're adding this hydrogen here and you're creating ethylamine, okay? This one here, we've got a tertiary, and here you have this hydride, and it makes triethylamine. So we haven't really got into what an amide is yet, but you can reduce this amide. We will get there in a couple of slides. Okay. What do we got here? Chemical properties of amines. They are weak bases. Okay. Ammonia has a pH of about 11.1. Okay. Not a strong base, but it's all right. Okay. Here we've got methylamine, which has a pH there of about 11.8. Okay. Aromatic amines, they have a pH there. They're very weak bases. All right. And what do I mean by a base? Bases produce hydroxide. And you'll see here, like ammonia is a weak base. What it does is you put ammonia into water. It doesn't add hydroxide. What it does is it steals a hydrogen from water, which then makes hydroxide there. So these chemical reactions here, you know, everything is fair game. It's open book there. So even as I said there before, as far have cheat sheets ready to go as far as naming all the different carboxylic acids and esters and amines and all that. Also have all the possible chemical reactions for each as well, for your reference. It's open book. Use everything you got. Amines are much more basic than amides. All right, and we'll get into what an amide is. So amines are more basic than amides. Why amines are weak bases? Okay, because they make ions, like we just showed you there before. Okay, amines are also a source of positive charges on biological molecules. The neurotransmitter dopamine and serotonin are typical examples of these guys here. So they're really good at making ions. And you'll see here, this should be NH2. But what happens is if you put this guy orthomethyl-aniline into water, what will happen is the NH2 will steal a hydrogen from the water as it did right here, and it will make, okay, an ion. And here we've got ammonia, put it into water, steals a hydrogen, it becomes ammonium. All right, and you'll have a look here. Here we've got orthomethyl-anilinium ion, and the same thing here, dimethyl, okay, has made an ion here because we put it into water, and this guy here has stolen a hydrogen from the water. Neutralization forms amine salts here. An amine salt, okay, forms when amines such as those responsible the odor in fish are neutralized by acids. Okay, so that's why you put lemon juice on a fish, right? It gets rid of that fishy smell, fishy taste. Okay, and there we go. Good. What do we got here? Now we get into the amides. Now an amide bond is this guy here. Okay? It's that carbonyl group. There's a good word. I wouldn't write that one down. Carbonyl is that C double bond O. So where do we find carbonyl groups? We find them in ketones. We find them in aldehydes. Okay? We find them in carboxylic acids. You also find them in amides, because this C double bond O to another to a nitrogen, this whole thing is called an amide bond. All right, and the naming is basically the same as amines. And you have a look here. Let's try and name this. How would you name this? Well, first thing, identify the functional group. Okay, I've got a methyl group there, I've got an ethyl group there, I've got an ethyl group here. Oh, I have an amine. Wait a second, that nitrogen that's an amide. All right, so you would write amide. All right, and now what is going on here? I've got a methyl group going on here, and I've got an ethyl group going on here. And the this is an old school name there. I'll show you there's some new school names. I don't want to confuse you. All right, but you'll see there, because it's tertiary, you are going to have an NN and diethyl. All right, this is an old school name there. Don't worry about that. We'll get into more naming as we go. All right, but as far as making these amides, here you've got this one right here. Okay, and you add your amine, and what happens is you're making your amide. So let's have a look here. What are we? Sources and uses of selected amines. We'll come back there to amides there. But histamines, okay. You guys, I'm sure you guys have taken now, and you guys know what a histamine is, okay. People who get allergic there to dust and pollen, they take antihistamines, because histamines there are your body's way of fighting bugs, fighting foreign invaders, dust, pollen, these kinds of things. And even when they're not really a threat, that's why we're kind of, people are allergic to peanuts, these kinds of things. And you take antihistamines there to reduce the swelling, to reduce the symptoms. Another example here of an amine there, we have norepinephrine, okay, epinephrine, all right. So I think that is covered up. There we go. You see there's my amine there for epinephrine. Here's my amine there for norepinephrine. Okay. All right. Exciting stuff, I know. Have a look here. Nicotine, cocaine. Well, we got methadone, caffeine, methamphetamines. Okay. And these guys here are all amines to some extent. All right. And you can see there that some of them there are pretty wild. All right. Stimulants to the extreme. Amides, nomenclature and physical properties. Okay. Amides there, they're neutral nitrogen containing compounds. They're not really acidic or basic. They're kind of neutral. Okay. Molecules are both in aqueous solution or as a pure substance. Contains a carbonyl group, which is directly connected to a nitrogen group, as we said there earlier. Okay. And these guys here are amides. And you can have kind of primary, okay, secondary. All right. So let's have some naming here. We've got a carboxylic acid plus an ammonia. All right. That'll make here an ammonium salt. All right, with a bit of heat there we'll make our amide. Here we've got ethanoic acid, which is just vinegar, plus an amine. We'll make this ammonium salt. Okay, we heat it up, and there we get our ethanamide. You have a look at that? How would you name this? All right, we've got, you identify there that this is an amide, and we have our ethane group on here, so just simply ethanamide. All right. What else we got? The IUPAC rules for naming these guys. Let's see if I can blow these guys up here. Oh yeah, I have a coffee. So let's have a look. Here we've got methanoic acid, 1 carbon, COOH, methanoic acid will become methanamide. Okay, simply that's it. 1 carbon, methanamide. You identify the chemical structure, or the what's the word I'm looking for? The functional group, which is an amide. 1 carbon would be a meth. 2 carbons would be an ethanamide. You have a look here. Now, this amide, and identifying this guy here you've got a methyl group, here you've got a methyl group. First you identify the amide. All right, so it's an amide, and what is going on? I've got N-methyl, okay, ethanamide. This is the one I want you to know, not this one. This one here is old school. I would never ask you to identify it this way. This is the way I want you to identify this. So this is ethanamide. Eth, because there's 2 carbons. It's an amide group. So right here, this is ethanamide. And because this is a secondary, you've got to have an N. So that'll be N-methyl ethanamide. Is cool? What else we got here? Oh yeah, this one down here. Hey. No. There we go. So you have a look here. And again, there's your amide. Find your longest chain. That is attached to the carbonyl group. Okay? So, sorry, in this case here, you're not looking for the longest chain. You're looking for the chain that is attached to the carbonyl group. So it doesn't matter. Here you could have 5 carbons. Doesn't matter. This is the first thing you name. This is the backside here. So I have 1, 2, 3. So this would be propanamide. And remember, start from your backside, propanamide. And this is a tertiary. So you must have 2 N's. Here I have an ethyl group. Here I have an ethyl group. So it will be NN diethyl propanamide. That's how you do these. Okay. Welcome to benzene here. Here we have benzoic acid. Okay. And if I fool with this, I can make benzamide. That is its name. Benzamide. Okay. Sorry there, I got the kids there downstairs. That's probably the hardest thing, is trying to keep them occupied. Poor kids. We take them out for a walk. We live by Georgian College, so we take them there for a walk through Georgian College there, because they've closed all the parks, rightfully so. So I'm just trying to keep them safe, and I hope you guys are doing the same. Welcome there to anyone who just has come in late. Don't worry, you haven't missed anything, because I've been recording the whole thing. I'll post it on YouTube. You're good to go. Physical properties of amides, hydrogen bonding, because of that carbonyl group. Oxygen is hugely electronegative, and it will hydrogen bond. Very polar, high water solubility. Okay, has a high melting point, high boiling point, and colorless and odorless. Okay, it's not like the amines where they are odorless. Amines are very stinky. Just think rotting fish. Okay. What do we got here now? Hydrolysis. Hydrolysis, here we're talking water. So here you have an amide. Can you name this amide? All right. So you identify the amide. That's an amide bond. 1, 2, 3, 4. Butanamide. All right. Plus water in acid. Okay. And what you're doing is you're basically exchanging, you're kicking this guy out, and you're adding an OH. All right. So now you've made butanoic acid. All right. And here we have a basic hydrolysis here. You have the same thing here. I have methanamide plus sodium hydroxide. We'll make this guy here. All right. We've got the salt of methanoic acid. Okay, sodium methanoate. And we've got NH3 here, ammonia. So, again, here is this strange configuration there of hydrogen. It will reduce. So if you see this is a hydrogen isn't always +1. It can be -1, which will change its chemistry and how it interacts. And you'll see here, here I have the amide. If we add the hydrogens here, what you're doing is you're removing this carbonyl group. Okay. Here I've got a tertiary amide. If I add this guy here, what you're doing is you're removing the carbonyl group. Okay, and you're just making, so reducing an amide will always produce an amine. Reducing an amide with this H minus will make an amine. Okay. Urea is a diamide. Have a look. Does it make sense? Here I have an amide. I have an amide here, a diamide. Metabolite of the body used to excrete toxic ammonia. Okay, white solid, melting point 133 degrees Celsius, very soluble in water, found in fertilizer. Okay. And there's a reason why we, basically this amide bond, or say the amide right here, is crazy important. And we're going to get into that right now. Welcome to protein structure. A polymer substance composed of many amino acids linked together. That's what muscle is. Muscle, you know, you guys have done your actin myosin fibers there. I think it must have been week 2 or 3. It's all just a bunch of amino acids linked together. All right. Here they all are. I'm not going to ask you to memorize these in any capacity or whatever. Actually, you know, they all work differently. And you'll see here that these amino acids, they all have these kind of the same structure. And they all have a carboxylic acid group, and they all have a nitrogen group. And that's what makes them so interesting. Sorry, I'm blowing in and blowing out here. This is a typical amino acid where you have a central carbon with a hydrogen. They all have this. And then you will have a carboxylic acid coming off of that central carbon. You'll have an amino group coming off that central carbon, and you'll have a different R group. That's an amino acid. Has a hydrogen, carboxylic acid, an amino group, and you have a different R group. Now this R group could be polar, non-polar, could be something, and over billions of years of evolution, it blows my mind, but the body has come up with these amino acids that, depending on whether this one here is polar or non-polar, proteins, muscles are made in the body, which is, you know, we're water bags, so water is polar. So if you need a certain three-dimensional model for a protein, well, this thing, if you're linking amino acids together, then you're going to need some non-polar R groups, which are then going to fold and configure and contort into a three-dimensional shape for you that will serve your purpose. And we'll get more into that there in a little bit. Okay, so this is the basic structure there for an amino acid. The variable R group, commonly referred to as the side chain, can contain alkyl groups, aromatic groups, all these different things depending upon the purpose that the body would need it for. And you can go back up to this one here and have a look at them. Some of them there are quite crazy. Alpha amino acid classifications based on the side chain, that R group, can be nonpolar, can be polar, can be acidic, or basic. And again, it all has to do with the nature of the amino acid and the purpose that it's being added into the chain of amino acids, which are then going to contort and make a three-dimensional structure, okay, for whatever purpose, whether it's amylase protein, the digestive enzyme in your mouth. It has a certain three-dimensional structure that locks and only locks onto starches, like bread and rice and these kinds of things, and then breaks it. It has a perfect three-dimensional structure. How did the body come up with this over billions of years? It just blows my mind. You know, some animals, I guess, didn't make the particular protein, so therefore they couldn't digest starches, so they died. Some mutant creature came up with a three-dimensional structure there that was able to break starch down, and they survived, and Darwin's theory of evolution. Okay, what do we got here now? Again, this is more about the R group here. These based on the ratio there of the amino and the acid group. The word I'm looking for, though, is, where did I see it? It's coming up. This is a good one here to know. The alpha carbon, this is that central carbon. Now you will remember, you want to write this one down, chirality, C-H-I-R-A-L-I-T-Y, okay, chiral. Now, we talked about that there, I think it was week 8. I think it was week 8, where if you have a central carbon with a hydrogen, you can actually change. Remember the mirror image? Okay, so if there's a mirror ray here, well, here I have a carbon, here I have a carbon, here you've got your carboxylic acid, your ammonia, here you've got a methyl group, and here you've got a hydrogen. And they look like they're the same, but remember, it's almost like a left-handed, right-handed thing. They're not the same, okay? And what we've got here, we've got a D configuration, NH2 to the right of the alpha carbon, and we can have an L configuration where the NH2 is to the left of the carbon. So just something there. You can have a D configuration. Now this is only when we're talking chirality. All right. So here we have the amino acid alanine, but it's a D configuration. Here we have alanine again, the same amino acid, but we have an L configuration. Again, I'm not going to go too crazy on that. There might be a question on that there in the final. So the amino acid has one chiral carbon, which is shown in red. Okay? Right here. So you have a look there. This is not a chiral carbon. Why? Because it has 2 of the same thing off of it. This is a benzene ring. No chirality there. This guy here is locked up in a carbonyl group, so there's no chirality there. But you see here, this carbon, it has one thing on here, it has a hydrogen here, it has a whole nother thing here, and then it has another thing here. So this one here can be chiral. All right. This is the word I wanted. Amphoteric. Amino acids can react as acids or bases. And you see, all amino acids, they have this acid group, and they also have the amine group. So this is a base, this is an acid. So amino acids can act like acids or bases. And you see here, I've got my amino acid plus NaOH, which is a very strong base. What's going to happen? All right, the hydrogen off of here is going to jump onto the OH, okay, and now you've made this ray here. Okay, you've made this ion plus water. If I put the exact same amino acid into hydrochloric acid, this guy here is going to jump. The hydrogen, is going to jump onto here and make NH3 plus. Okay, so they will react in acids or bases, like an acid or a base. Definitely this one here, write this one down if you can. It's called a Zwitter ion. Okay. Formed by amino acids in neutral solutions. Basically what happens is in a neutral solution here, the hydrogen off of the acid end will go right onto the amino group. This is the basic end, and it's kind of ionizing itself. So it's called a Zwitter ion. Okay. Zwitter ions can react as an acid or a base. Again, same kind of thing here. You put this protein Zwitter ion into a base. You would expect this to happen. The hydrogen comes off and makes water. you put the same zwitterion into an acid. Okay, what goes on there is that guy here jumps onto here. All right, so that's that. The amide is formed. See here? Here is my amino acid. Okay? Here's my acid group. Here is my NH2. All right? What happens is the acid group will react with the base group of another amino acid. And this is how the body links amino acids together, keeps linking amino acids together to eventually get muscle tissue. All right? And what happens, the water gets sucked out, dehydration, and you end up making the amide bond. Okay? So an amide bond here between amino acids is just another word for the peptide bond. Okay, amide bond formed between the COOH group of one amino acid with the amino group of the other. Okay. Again, the amide bond is equal to the peptide bond. All right, there's your amide. All right, and as we said there, the acid group of one peptide bond forms with the NH2 group of another amino acid to make the peptide bond or the amide bond, which is right here. Okay. This is kind of neat. I don't know. I'm sure you guys have covered this there in bio already, but the linking of amino acids together in a single chain. Okay. Where does that happen, by the way? The ribosomes. That's what happens here, and you get this single line, okay, of amino acids there to come together. But depending upon the R groups, whether they're polar or non-polar, because you have to think this is all water, right? This is occurring in the cell. Okay, the tRNA is making these guys, is bringing in the amino acids there in the ribosomes. Okay, this is all water. Water's polar. So, okay, fine and dandy, but then we'll start to get some non-polar or different R groups there, and then this single chain will start to bend and fold. All right? And we've got alpha helix, okay, DNA. We've got beta sheets. They're kind of sheets, all right? And what will happen is now these things will start to bend and fold and contort. And you have a look here. Here we have tertiary structure. Okay, primary, secondary, tertiary structure here. Okay, where we get bending and folding. Quaternary structure there is where you get different folding units coming together to make a bigger unit. And you look in the inside of here, that's going to be non-polar. Absolutely. So all these R groups in here are non-polar, and they're folded away from the water. All right? And because obviously this is the lock to a key for some other type of, maybe this is amylase in your mouth. And this is the exact three-dimensional structure for it to unlock a starch molecule and break it down. Okay, we're getting there. There's only about 10 more slides, so hold on. More about the amino acid. Anything interesting on here? This is just a review, and you guys can have a look at this. It's just kind of the same slide going over the same thing. Okay. Amphoteric, kind of like auto-ionizing itself. Okay. And it works in both ways. Amphoteric means there that it can react as both an acid or a base. Your zwitterion, auto-ionizing, again, it's that acid-base thing. Okay. Yeah, peptide bonds. We're good there. Yeah, this is all review. Perfect. Polyamides. Condensation, polymers that contain repeating amide linkages. Okay. Polyamide makes sense. Peptide bonds, peptide linkages. Yeah, same thing there. Nothing new. Geez, I could have made this a lot shorter. Formation of polypeptides. Again, this isn't too bad. Tripeptides, tetra, penta, polypeptides, proteins. It's all just getting into longer and longer chains. Okay. At least 50 amino acid units here. We're talking protein structure. Serves as specific biological functions, and it must have a defined shape. When you're talking protein structure, shape is everything. Okay, and described on 4 levels that we've already talked about there: primary, secondary, tertiary, quaternary structure. Okay. Sorry, right here. Again, your primary structure is all linear. Great word there. Okay. Secondary, we start getting into the beta sheets, the alpha helix. Okay. Tertiary, 3-dimensional folding. Okay. Pattern of protein due to the side chain interactions. All right. Quaternary structure, you'll see here. I think this is heme, heme. There's 4 hemes there. They come together there and they make a bigger protein there, hemoglobin. Okay, so that is your quaternary structure there. Some examples of proteins and their structures: fibrous proteins there. What do we have? You'll see all these. These are all protein, keratin, these kinds of things. Protofilaments, microfibrils. Okay. And there's your keratin there. There's your alpha helix. You coil a couple of them together. You get this one right here. You add more and more, and you see how this turns into this. Some examples of proteins. Fibrin. Here's silk. Here's some beta sheets. Collagen. Okay, collagen protein forms a triple helix. One strand is blue, one is red, one is green. Myoglobin, again, here's your quaternary structure. All right, you guys are all familiar with myoglobin. Please know there that hemoglobin, that's in the blood. Where is myoglobin found? In the muscles, which is the reason why you're able to run 100 meters right now, because you have that stored oxygen already in your muscles. Macromolecules, we got polymers, monomers. Polymers there are these large molecules. Monomers there are the individual units. All right, that repeat and repeat. Plastic means a variety of polymer substances like nylon. I think was the very first commercially made polymer. And these are all polymers right here. Okay, you can have a look at those. And normally the carbohydrate section is quite extensive, but I've killed it to include only a couple of different things here. Jeez, I got a cough. Here we go. Carbohydrates. These are the principal class of energy-yielding nutrients. Okay. Carbohydrates are polyhydroxyaldehydes or ketones. Okay. And generally we see glucose, these kinds of things, written in a ring structure. But it can also be written like this. There are 4 types of carbohydrates: monosaccharides, disaccharides, oligosaccharides, and polysaccharides. Please know a situation for each of these here. Okay, we've got glucose as a monosaccharide. I think that's on your quiz there, that's out there. Okay, we've got sucrose. All right, oligosaccharides are carbohydrates with at least 2, but not more than 6. So sucrose. All right. could be an oligosaccharide. Okay. We've got polysaccharides like starch, cellulose, these kinds of things. These are what we call polysaccharides. And that's all I got. That is all I got. Do you guys have any questions? No? I think you guys are going to do very well. I think your quiz is due there this week. I forget when. I don't even... What day is it? So make sure you get those in. I think your lab is due there next week, your final lab. I should be marking your lab 5s there today or tomorrow. Your quiz 5s for sure there tonight. So, but just keep at it. I'll be updating you there about the test as next week comes, but it'll be next Wednesday for sure during this time. Now, I'm not going to give it to you over 3 hours. What I'll do is I'll probably give it to you over 12 hours. You can print it off, take your time, relax. It'll probably be somewhere between 60 and 80 questions, all multiple choice. You hand in the answer sheet as you've been doing there with the quizzes, and that's it. I think you guys are going to do just great. If you guys don't have any questions, get out of here, go and enjoy your day, and get back to work. Take it easy, guys.
Sorry, Ian, is the test cumulative, or is it just based, like, the midterm on?
The test will be everything from, what, week 8? Week 7? What, yeah. Sorry, did that answer your question? Yeah. Everything there from, you remember all the horrible math from the first 7 weeks? Nada. There's nothing on there from cool. That. It's, so this is only on organic chemistry, everything there that we've been doing. So the things you want to look at there for next week will be your 3 quizzes. Oh yeah, I'll post the answers to quiz 4 and 5 there probably tonight or tomorrow. The answers there for quiz 6 I'll post after quiz 6 has been handed in. You want to hit the assignments there. I'll post those answers, and that's all you're looking for those guys there.
Thank you.
Good. Any other questions?
I just have a question for the assignment.
Uh-huh.
It's question 39 to be specific. It says which of the following represents an incorrectly named compound, and all the options are 2 pentanone, 3 pentanone, 4 heptanone, and 3 hexanone. But they all can be ketones because they're all in the center. Is that what I'm...
I don't have that in front of me here. Let me, can I do that? Let me see here now. Let me move that. Can I? Okay. So, let me, where would that be here? Georgian stuff. Georgia, yeah, 109. That was what, assignment, quiz 6?
3.
Assignment 3. Assignments. I have it here. Yeah. So, what is it here? What question is that? 39?
Yeah.
Alright. Which of the following represents an incorrectly named compound? So, what you're going to have to do is draw them, and one of them, the name is bogus. Now, and generally these will have to do with the number. Incorrectly, counting from the wrong end. Do you know what I mean?
Oh, okay.
Yeah. So draw those out, and you'll see which one is a bogus answer.
Just now, just looking at it.
You got it?
Yeah, thank you.
No, it's all good. It's all good. What else you guys got? That's it? Well, I have to say I am going to miss you guys. Some of you guys I probably won't see again. That's just the way it's always worked out. And I'd like to shake all of your hands, but I won't get a chance to. I guess Georgian has gone virtual there for the summer as well. So I think they're the last 3 weeks of August, like all the chemistry labs and all that kind of stuff, they won't be done. You know how we have Group A, Group B. They won't be done until the second week in August, where it's only going to be chemistry labs. So if I don't happen to see some of you again, you guys take it easy, be safe. Please keep asking questions there. Some of you guys have been apologizing to me, and I've been replying back, please don't, okay? Don't apologize at all. Hound me, irritate me, bother me. I love it, okay? Let's get you guys through with the best mark you can bloody well get, all right? And fight for your life, man. You guys have a week to go. Keep at this, and if I don't see you again, you guys have my email, all right? Email me a year from now, 6 months from now. I have resources that you do not. I still have students there that I talk to. One's at Ryerson, another one there at Guelph, who went into nursing and then went on to veterinary. So it's all good in the hood. You guys just be safe, take care of yourselves, and fight for your right to exist and get the A there that you guys need to, okay? I'll post this there on YouTube. I'll show you where if you haven't hit YouTube yet, but you guys take it easy and be safe, okay? All right. This is Ian signing off.